Hello all. Today in this video lecture we will see this different numerical on resolution of forces chapter, and in this numerical we will resolve oblique components. So we will find magnitude of those oblique components. So before that, just understand this numerical. So our numerical is resolve the 60 Newton force into components acting on u and v axis and determine the magnitude of the components. So here see cursor of my pen. This is u axis, this is v axis, and this is 60 Newton force. So we will resolve this 60 Newton force along that u and v axis. So just understand this as u axis and this is v axis. And in numerical they told us that we will resolve those u and v axis, like we will resolve those components along u and v axis. So see, along u axis we will consider this component, because see this 60 kilonewton is like that. So resolve this 60 kilonewton, and along v axis components will be like this. So let us along u axis nomenclature it as f1, and along v axis nomenclature it as f2. So here in this numerical, as you all know that for solving oblique components we need both angles. Just assume this as f. Between f and f1, this angle assume it as alpha, and between f and f2 this angle assume it as beta. Between f and f2 angle beta. So we will need both angles, alpha and beta. So geometrically observe this diagram, how to calculate alpha and how to calculate beta. So if you will see geometrically this diagram, then geometrically you will understand this 40 degree here, this is 40 degree, so this will be also 40 degree. And here one thing is this angle is 120 degree, so your alpha will be 120 degree minus 40 degree. It is 80 degree. Now calculate beta. So just see this axis, this angle will be 180 degree. So 180 minus this 120 degree will be your beta. Just see, your beta will be total 180 degree minus 120 degree. That is 60 degree. So this beta will be 60 degree. So both alpha and beta we calculated. Now we will see components. Components along u axis, that means component f1, oblique component f1. So how to solve this oblique component f1 is equal to f, this is formula sine. So now we are calculating this f1 component. So angle between f and f1 is alpha. but in numerator this alpha will not come. In numerator this opposite angle beta will come. So just remember this thing. And upon sine of both angle will come denominator alpha plus beta. So F is given quantity, F is 60 Newton, and this beta is 60 degree upon sine of alpha plus beta. Alpha is calculated already 80 degree and beta is 60 degree. This F1 sine of 60 upon sine of 80 plus 60 into 60, it is 80.84. and Newton. So here 80.84 Newton is our F1 oblique component. Now similarly we will solve F2 oblique component. Just see how we are solving it, like which angle we are considering. Just remember formula, those things are important in for solving of this numerical. How we are calculating angles, how we are applying geometry. Component F2. So F2 component is equal to again F upon sine. Now now this component is different, so here numerator will be different, numerator angle will be different. So between F and F2 component is beta, but do not consider this beta here, consider opposite angle alpha. That means angle between that force F and another component angle upon sine of alpha plus beta. So again this F similarly 60 Newton and sine of alpha is 80 degree and beta is 60 degree. So sine of 80 upon sine of 80 plus 60 into 60, it is 91.93 Newton. So this F2 oblique component is 91.93 Newton and F1 oblique component is 80.84 Newton. So initially our objective was to calculate along U and along V axis components of that F force. So we consider that F1 and F2 oblique components, we calculated alpha and beta angle, like angle between those components and that F force, and like with the help of formulas we solve this numerical. So thank you very much.